Hi guys, welcome to our weekly review videos. I'm opening up my calculator now so we can use it. This is for the week of November 8th to November 11th. Alright, so let's take a look. First thing we did this week was we graphed quadratic equations, which we have been doing for a really long time now. In order to graph, we're going to press y equals, and we get the screen on my right. Let's go ahead and enter our equation. That's negative x squared plus 4x minus 2. And then remember, after this, to get our table of values, you're going to press second graph. Okay, if you do that, we end up getting our table of values. And we want to write down the points that we're going to be able to plot. So notice that you cannot plot to negative 14, right? Because our graph only goes up to positive and negative 10. So we're not going to write that down. Negative 1, negative 7, I can definitely plot that. 0, negative 2, that's another one. 1, 1. 2, 2. 3, 1. 4, negative 2. And 5, negative 7. And you'll notice that if I go to our next point, I get 6, negative 14. Again, doesn't fit on our graph. Let's go ahead and plot this. Negative 1, negative 7. 0, negative 2. 1, 1. 2, 2. 3, 1. 4, negative 2. And 5, negative 7. Let's connect our graph. Or connect our point, excuse me. Ooh. See, big no-no, right? Because that looks like too pointy. It should be U-shaped. Remember, when we graph this, it is a parabola. There you go. Much better. And then it says, let's label these different points. So I want to label my y-intercept with a y. Remember, that's where we cross the y-axis. So that's right here. I'll label this y. Our vertex, label that with a V. Our vertex is our turning point, that is here. And then our zeros, there's going to be 2 of them. Let me do that in a different color. And we want to label that with a Z or 2 Z's. And our zeros are where we cross the x-axis. That color wasn't dark enough. So right here. They're hard to read on the graph. That's okay. All we're doing is we are locating them. I'm not giving the actual point. Alright, go ahead and take a minute, see if you can do this one, pause the video, otherwise I am going to get started. So again, the first thing we're going to do, we're going to go to our calculator and press y equals. Remember, anytime we want to graph, that's what we do. Let's clear this, and then we're going to press enter our equation. To get a fraction, we're going to press alpha y equals. And then enter. Okay, so if I press alpha, y equals enter, you notice we get a fraction, and now I can enter my equation, right? 1/2 x squared plus 4x plus 4. And then again, we're going to press second graph to get our table of values. Really crazy numbers, right? So notice our numbers are getting really, really big. These are not the numbers we're going to want to plot. I'm going to want to scroll up and down until I can find numbers I can plot. So, 0, 4. Negative 2, negative 2. Negative 4, negative 4. And I'm skipping those decimal ones, okay? Skip the decimal ones, skip the fraction ones. We do not need to plot them. There's going to be plenty of points. Negative 8, 4. Let's see if there's any more. Okay, negative 10 gives us 14, and that's it, right? Because any other points past that, like negative 11, it's already off our graph. Okay, so negative 8, 4, negative 6, negative 2, negative 4. Whoops, that was the wrong point. Negative 6, negative 2, negative 4, negative 4, negative 2, negative 2, 0, 4. So just make it a little U shape, and it looks like that. Let's go ahead and label our points. Our y-intercept is where we cross the y-axis. That is our y-intercept. Our vertex is our turning point. That's down here. And then again, our x-intercepts, or our zeros, or our roots, where we cross the x-axis. And there is 2. Alright, so that's one thing we did. The next thing we did was we worked with word problems. And we'll review this by going over page 14 and 15. Let's take a look at this example. Example 1 says a baseball is thrown into the air with an upward velocity of 30 feet per second. Its height, h, and feet after t seconds is given by the function h of t equals to negative 16t squared plus 30t plus 6. How long will the ball take to reach its maximum height? The first thing I want to do is I want to sketch what this graph is going to look like. So I notice that my a value is negative, so that tells me that our parabola is going to be like sad. Okay, so now I know what my graph looks like. This is what my ball is going to look like. If we're looking for the maximum height, we're looking for this point over here. And that is going to be our vertex. So we are looking for our vertex. Remember, to find our vertex, first we need to find our axis of symmetry using the formula x equals negative b over 2a. Let's go ahead and identify our a, b, and c values. A is negative 16, b is 30, and c is 6. So let's plug in. X equals negative 30 over 2 times negative 16. Go back to our calculator. Let's put this in. Alpha y equals, to get a fraction, negative parentheses 30 on top. Close your parentheses. 2 parentheses negative 16 on the bottom. And I get a decimal. And that's okay. X equals to 0.9375. Okay? But be careful, because this is the time it took for the ball to reach its maximum height. Okay, if we want to find the height, I need to go ahead and plug this into my original equation. So that was negative 16 t squared. I'm going to need more room for that. Plus 30t plus 6, and we're plugging in 0.9375, 0.9375. Let's go ahead in our calculator. Negative 16 parentheses 0.9375 squared plus 30 parentheses 0.9375 close parentheses plus 6. So this gives us 20.0625 feet. Okay, so I want us to really understand what we did here. When I solved for the axis of symmetry, I got the x value, which represents the seconds. This answers our first question, how long it took to reach its maximum height. Its actual maximum height is 20.0625 feet. Okay, let's look at this one. You can go ahead and try it by yourself before we go over it. But let's go ahead and try it. The height of an object that is traveling through the air can be well modeled by a quadratic function that opens downward. An object is fired upward, and its height in feet above the ground is given by this function. Where the input t is the time in seconds, the object has been in the air. So part A says, using your calculator, sketch a graph of the object's height for all times where it is at or above the ground. Okay, so we're using our calculator to graph. Remember, step 1, y equals. Let's clear this and let's put this new equation in. Negative 16, our calculator doesn't have t. I mean, it does, but it's not going to calculate it for you, so we're going to use x. Negative 16x squared plus 64x plus 80. Remember to get our points, second graph. And these points are way too big, right? Take a look at our numbers. I want to go all the way to 0. I don't have negative numbers. So, x, y, 0 is 80. Let's understand what that means. That means at 0 seconds, our object is at 80 feet. At 1 second, our object is at 128 feet. At 2 seconds, our object is at 144 feet. At 3 seconds, our object is at 128 feet. At 4 seconds, whoops, sorry, my hand slipped. At 4 seconds, our object is at 80 feet. At 5 seconds, our object is at 0 feet. And then look at this next part. At 6 seconds, our object is at negative 112 feet. We talked about in class that doesn't make sense, right? Doesn't make sense for our object to be negative feet. So let's ignore that and plot what we have. So 0 is 80. 1 is 128. That's somewhere near here. We're just taking a sketch. It doesn't have to be beautiful. At 2, I made it wrong. 128. At 2, we are at 144. So that's about right here. At 3, we're back at 128. At 4, we are at 80. And at 5, we are at 0. So our graph looks like this. Okay, just be careful because in real world problems, we do not draw arrows. Arrows would mean that we go into our negative numbers. We don't have negative numbers here. So let's answer these questions now. B says, what is its maximum height in feet? Remember, this is the course of the object, right? It goes up and then it comes back down. So our maximum height is going to be this point right here. Just be careful. This is the point 2, 144. And you have to think about which one of these numbers represents our maximum height. It is going to be 144 feet. The 2 represents 2 seconds, right? We had said earlier at 2 seconds, our object is at 144 feet. Okay. Let's take a look at the next problem. At what time does the object hit the ground? Hit the ground would mean that we are at 0 feet. So let's see where our object is at 0 feet. Our object is going to be at 0 feet over here, right? So it goes up and then it comes down and we hit 0 feet after 5 seconds. And last but not least, over what time interval is its height increasing? So we're talking about increasing. Let's first label it on our graph first. Our height is increasing over here. Okay, and when they ask you over what time interval, well, that's between 0 and 2 seconds. And that is all, guys. If you had any questions, feel free to comment, feel free to email me, feel free to reach out to me on Pupil Path or just ask me a question in class, okay? Thank you for watching. I really appreciate you working on yourself. Have a good day.